If we want to go ahead and move to a point of no lead in the water in your school, then what are those incremental steps to get there? We know that the piping out on the street might be full of lead, so we have to start to replace that. That's a multi-year, multi-million-dollar project. But in the interim, we will not allow kids to drink from the water fountains, and we'll bring in bottled water. It's the same kind of concept. To get to a place where kids are no longer drinking lead out of the faucets in their school, it took a long time of education, political will. Air quality is going to become comparable, and it is going to, the political will, I believe at this point, is there. Funding is also coming down, and I also look at what is the downside of improving your air quality. It is some energy penalties, and then there will cost more, but ultimately schools are there to educate those children, and it is our civic responsibility to make sure that environment is as conducive as possible to that learning environment. So yes, it is difficult, but at the same time, there was a time when schools didn't have any air conditioning, any heat, and that is just one of the decisions as societally that we've made. Air quality is not just about more fresh air. If you're in the California area, we don't want to be bringing in fire-laden air. So we have to start to migrate to having the levers and the capabilities to turn the air off or to filter it. And so I kind of see it as baby steps. Figure out what you have and then start to go system by system and improve their delivery of ventilation. Prerequisite is just figure out what you have and what condition it is. Just know what your filter sizes are. You have to know if there's a MERV 9 or a MERV 11 installed. Know the age of these systems and what level of fresh air that they can actually produce. Once you have a good sense of what your systems are capable of, then you can start working with your design professional to come up with the right priorities. If you have a school with zero ventilation, then the project is going to be put in ventilation. If you have a school with great ventilation because it's modernized, filtrations, everything's there, then it might be for air cleaners or sensors. So that's why everything is broken out into stages and step by step. The entire point of the guide is just start, just begin. It's not there for doing everything. It is going to be a program that school systems and owners are creating, a program for indoor air quality. It will take time to establish. New construction should follow it, but there are also plenty of legacy buildings that can be retrofit in certain classrooms, certain HVAC systems. Everything has to go back to what's best for the student, what's best for the learner. And so when you make the argument of what type of books to buy, what type of Wi-Fi to put in, it's all based on what's occurring in the marketplace. And there's plenty of research showing that good ventilation, good environmental conditions help with the learning environment. And it's pretty cut and dry from that standpoint. I would move away from any kind of pandemic or viral mitigation to what's best for the students. And you have to work within that funding stream to make that happen. We already know that they're not going to, in the northern climates, they're not going to learn if there's no heating, and that decision's been made. The stretch from having HVAC to having HVAC code mandated ventilation, all that's there. There's not much now that we need to do that's extra, except for monitoring, measuring, and then constantly rebalancing and testing. And I don't think that is that much of a lift in today's marketplace. So we do need to keep our buildings tuned up, and just like a car, and they do slowly go out of balance. And all these modernized buildings are great. They have plenty of ventilation based on code, and it's just about operational and educational time. So I think it is not that big of a lift. If you were talking to folks and go back to, well, what's best for the student? We expect tempered climate classrooms now. Anywhere in this country, it should be within a certain environmental zone, and that same goes with the air. Scientists and researchers have done a great job of bringing all the data to the forefront, but now it is the purview of engineers to execute on it. And it is important to have an engineer who can work with the existing systems to bring them up to the highest possible indoor air quality. So that's step one. Before you put in all new equipment, how do we get the most out of what we have? So I do believe a HVAC professional is vital to the team, but it has to be the team. It's got to be other stakeholders, such as the maintenance folks, folks who are going to be doing the filters. If they don't have a program to change filters every quarter or every 6 months, then they need to have a seat at the table. And then finally, you've got to have the customer, the parents, the teachers, administrators. And so they're educated on what all these numbers mean. We have a project where they put the CO2 values on the wall, and everyone panics when they see it spike up and then down. 5,000 parts per million for 8 hours is the OSHA standard, and it went from the ambient 455 to 1,200. Nothing crazy. As an HVAC engineer, I'm looking for it to go up and then start to come back down. That means my systems are working. But as soon as everyone sees it spike, it is panic, and that's why all the stakeholders have to begin the education. We all know at some level, good and bad. We don't get into the numbers. If I asked you what is a safe parts per billion of lead in water, you would just default to zero. Nothing. I want nothing. But there is some trace amounts that are acceptable, and that's in air quality, it's the same thing. It should be on the same level as energy efficiency programs and figuring out how your systems are operating. I'm not going to put it on the same level as life safety, but over time, just define it of what is right for the school. And any project that we do, that we think about, any program, putting in IT, putting in wireless infrastructure into a school, is right for the learner. And so there are plenty of studies out there where cognitive abilities go up when CO2 levels drop, and that's well documented. We do know good ventilation helps with the learning environment. So from that simple perspective, it's right for the learner, so then it must become part of the environment. When I walk into some school districts and you've got pipes leaking, it's a travesty. And it doesn't matter what type of curriculum there is, how good the teachers are. If the heat doesn't work in the school in the middle of winter, it's irrelevant. So it's all part of the whole package. We're a small piece of the puzzle, but we do need to make sure that air quality starts to help the learning environment, and it needs to be done that way from that perspective. So we've worked with, just on the ASHRAE guidance, probably around 70 or so different schools districts around the country, all ranging from one-offs to 200 schools. And so part of the guidance, it's seeing it sometimes go out of order. One district is just putting in sensors. One district, okay, well, what are you going to do with all the sensor readings? You're collecting billions of points of data a day, and then who is going to now aggregate that data and convert it into an action? So that's kind of where we are with them. Other districts are, what is my baseline? I just don't even know what I have and what tools I have. So my day job as a mechanical engineer is everything. I mean, that's the whole reason I'm able to understand what some of these systems are. And if you've got an RTU with 18% capacity of ventilation, then we know what that translates. If we don't know the distribution, then we bring in companies like Safe Traces to start to figure out what that distribution path is, and then you have a scope of work to improve it. And that's where it is very important for the engineers at some point to give the building owners the game plan, the solution. All of this right now is still in a testing phase, giving the owner overloads of information. They just need to get it solved. And so that's what our day job, that's what plenty of ASHRAE engineers, that's what we have been doing for years, and we will continue to do. I think the concerns are totally valid. So as soon as you put in a whole bunch of sensors, as soon as you test and balance the systems, you're going to have a list of work to do. There's no way around that. You'll find all different types of sensors that are broken, that control your HVAC, or you might not even know the filter sizes. I think from a school's perspective, it is a multi-year program. Figure out where you stand, figure out how it's operating, what works, and then before you start going public with your sensor readings or having a public dashboard, have the protocols in place to rectify it. So that is where I see the same game plan that testing for lead in schools came down. You know, they started testing, they had test regularly, then they figure out where the leaded pipes are, then they start replacing them, and in the interim you bring in bottled water. So I think in the same way you have to start, because it is something that is going to be important for the learning environment. I don't fall on the path of we're going to mitigate every viral introduction, and it's a COVID byproduct, but there is at this point, based on all of the sensor readings and testing across millions of square feet that we've done, you can tell that there's some really poor air quality in some of these classrooms, and that education is going to be a multi-year process. Now, why is it poor? Sometimes the teachers are just burning incense and air fresheners and cleaners and with Clorox bleach wiping down everything, every classroom. So that does degrade what that air is. So we got to at least ventilate it and flush it out. When you walk into a classroom and it smells like a hospital, just in your gut, you know that probably isn't good for those tiny lungs. The next version of the guidance, we're currently going through technical committee review and also ASHRAE publications review. We had a meeting with several stakeholders, and what they wanted to see is on the risk assessment section, more of it altered towards a planning and budgeting for equity. Now, equity is going to be defined for the people who are sending out the funding is, do you split your pot of money by square footage? Do you split it based on student population? Do you do it based on age of the building, or do you do it by the assessment, who has the worst air quality? So those are considerations in that next tranche, because the funding is not limited, but if you have $500,000, how do you best deploy that across a school district? It might not be logical to give each school $10,000, because that won't do as much. It might be more logical to give the whole $500,000 to the school that has no ventilation. So those are on the planning and the assessment side. It's important to work with your design professionals to figure out the best use of that.